Welcome back, everyone. This video begins the Test 3 material, and so just as a reminder, Test 3 is going to be on Friday, October 23rd, and the sections it's going to cover are 1, 9, 1, 10, 2, 1, 2, 2, 2, 3, 2, 4, and 2, 5. We're going to start today by talking about 1.9, which is about properties of graphs. So in this section, we're going to talk about how to look for various properties of functions in the graph, that is, how to read them off. And all the questions in this section are going to have the form, here's a graph, here's two functions, which of these functions is the one that this is the graph of? And I'm going to run through a few different properties that you can read off of the graph that you might look at to answer this question. So for these first couple examples, I'm going to look at reading off the X and Y intercepts. Okay. Now, from this graph, I can see here are the two X-intercepts, and here is the Y-intercept. Now, I don't have numbers on this axis, so I can't read off exactly what these numbers are, but I can tell that these are negative. So there are two negative X-intercepts. And also, there's the Y-intercept. The Y-intercept is positive. And so these things I've written down, these are properties of the graphed function. Now, roughly speaking, what do we need? We need to figure out which of these two functions would match these two properties. So here is function f, and here is function g. Okay. And since the y-intercept is easiest, let's calculate the y-intercept of each of these. So the y-intercept of f, that will correspond to, again, 0, f of 0, where f of 0 in this instance is 1 times 3, which is 3. So my y-intercept in this instance is 0, 3. Okay. Note that's a positive y-intercept, matching this positive y-intercept. Okay. Now, that doesn't tell us anything, because maybe both of these have positive y-intercepts, in which case this wouldn't help us. But let's go over and look at g now. The y-intercept here, be it 0, and then g of 0. But g of 0 is minus 1 times minus 1. That's plus 3. Okay. So this is, in fact, it has exactly the same y-intercept. So both of these match the information that I have about the function in the graph. So that is inconclusive. What if I instead now look at the x-intercepts? Okay, so remember the way I'm going to find the x-intercepts is by setting the output of the function equal to 0. So the x-intercepts of f of x are at minus 1, 0, and minus 3, 0. Note I'm expecting two negative x-intercepts. Hey, that agrees. So f agrees with all of the information I've written down here. Now let's look at g. For g, again, to find the x-intercepts, I set the output here equal to 0, which is going to give me x equals 1, x equals 3. And so that's going to mean that my x-intercepts here are 1, 0, and 3, 0. Note, this is two positive x-intercepts. whereas the graphed function had 2 negative x-intercepts. And so this does not match the graph. And so you're going to see that almost always the way we figure this out is to find a property that is present in the graph that is not present in one of these functions. And so in this case, the property we found is that g's x-intercepts are positive, whereas the graph functions are negative, which tells us the function in the graph can't be g, so the graphed function must be f. Okay. And so as an answer here, we can write a sentence that's something like, the graphed function can't be g of x because g of x has positive x-intercepts, but the graphed function doesn't. And so the graphed function is f of x. So this is a model of what all the exercises in this section are going to look like. We're going to have a graph. We're going to think about, hey, what properties do I see present in the graph? And then once we look at the properties that are present in the graph, we'll look at those properties in the functions and see which one matches and which one doesn't match. Okay, so here's another example. We have this graph, and we're told this graph is one of f of x, which is 2 plus the square root of 9 minus x squared, or g of x, which is 2 minus the square root of 9 minus x squared. So, like before, I want to write down the properties of the x and y intercepts. So for this, the graph here has no x-intercepts, and it has a positive y-intercept. That's my positive y-intercept. Now, if I look at f of x, let's start with the y-intercept. The y-intercept here is going to be 0, comma, and then this thing is going to be f of 0. F of 0 here is 2 plus 3, which is 5. And so the y-intercept here is 0, comma 5. And that's positive, it matches the picture. When I then look at g of x, and I look at the y-intercept of g of x, it's going to be 0, comma, and then this is going to be g of 0. And g of 0 is going to be 2 minus 3, which is negative 1. And so that actually does not match the graph. This is a negative y-intercept. And now I want to notice, we wrote down this information about x-intercepts, but we don't even have to think about x-intercepts, because as it happened, the first thing we checked, which was the y-intercept, already told us the graphed function can't be g. And so, when we go to write our answer, we'll write something like this. Okay, so just summarizing here, g of x has a negative y-intercept, but the graphed function has a positive y-intercept, so the graphed function can't be g of x, and hence it has to be f of x. Alright, so that's a couple examples of the sorts of graphs that we can distinguish by looking at the x-intercepts and the y-intercepts. But it's going to turn out that that's not enough to answer all of these questions. So in the next video, I'm going to talk about looking at positive, negative, and undefined outputs as a way of sorting out graphs. But that's it for now. I'll see you next time.